Okay, so example 1 asks us to consider the polynomials p of x and q of x. Part A asks us to find p of x plus q of x. So if we were to add p of x and q of x, we're going to get p of x is up here. That is 5x cubed minus 2x squared plus 7. And q of x is 3x squared plus 8x minus 6. Well, when we add these, this bracket, since it's being multiplied by just 1, right, it goes away. So we get 5x cubed minus 2x squared plus 7. Over here, this is multiplying by a positive 1, so this bracket can just be taken away. So we get plus 3x squared plus 8x minus 6. So now we have to combine our like terms. We have just one cubic term, so we get 5x cubed. We have negative 2x squared plus 3x squared, which gives us a positive x squared. We have just one term with x, so we get a positive 8x. And then we have two different constants, positive 7 and negative 6, which makes a positive 1. So this represents the sum of both of these problems. Now, part B asks us to subtract the two of these terms. So how is this going to look different? Okay. Now, if we were to subtract these two terms, so now we're moving to problem B, then we have to change the sign to subtraction. Now, when we subtract away q of x, we have to distribute that negative here to each term. Okay, so it's very important to keep this thing grouped together, to keep it inside its bracket. So our first term remains the same. And now this negative is going to multiply by each term on the inside of the second set of brackets. So the negative times 3x squared makes negative 3x squared. Our negative times 8x makes negative 8x. And then the negative times the negative 6 makes a positive 6. So again, we're going to have to group these together. We're going to get, we only have a single 5x cubed. We have a negative 2x squared and a negative 3x squared, which makes negative 5x squared. We have just one single x term, so we have negative 8x. And then we have a positive 7 and a positive 6, which makes a positive 13. So that is what our two terms are added together. Now, when we went back, when we look at question or part C, which asks the value of p of 3 plus q of 3, we could think of that in two ways. We could plug those numbers into each function individually and then add them together. But if we already have the functions added together, we can just plug those numbers in. So let me show you what I mean there. So part C asks us to evaluate what p of 3 plus q of 3 is going to be. Well, we know that from down here, we know that p of x plus q of x, that was 5x cubed. This is from earlier. Plus x squared plus 8x plus 1. So we are going to go ahead and plug our 3 into that. So we're going to bring this up. So this is like 5 times 3 cubed plus 3 squared plus 8 times 3 plus 1. So we need to go ahead and actually evaluate this. So 5 times 3 cubed is 5 times 125. We have 3 squared is 9. 8 times 3 is 24. And then our positive 1 left over. So now we just need to evaluate this. 5 times 125 is 625. We have the plus 9, the plus 24, plus 1. That should make plus 35. And so we have 660 being the answer to our problem. Now, part D asks us what the degree of this whole thing is going to be. So the degree of p plus x plus q of x. Well, our degree is the greatest exponent of x in a polynomial. So when we look at our exponents, we've got 3, we've got a 2, we've got a 1, and then technically this is an x to the 0. So our degree is the highest value exponent. So in this case, the degree is 3.